Hello everyone, welcome back to the channel. Today we will be looking at a simple but tricky question. This LEETCODE medium level question has been asked at a lot of top tech companies. But before moving on to the question, we have an announcement for you guys. We will be giving away LEETCODE premium subscription every month, and the rules for the giveaway will be announced at the end of the video. So please watch the whole video to enter the giveaway. I would also like to congratulate those who joined our Discord group. I can see our community growing day by day, which is helping a lot of students and everyone preparing for technical interviews. As always, all the links to website and community groups are given in the description below. So that being said, let's dive into the video. So the question says that we are given a message containing letters from A to Z, and it has been encoded to numbers using the following mapping. 1 maps to A, 2 maps to B, and so on until we reach 26, which maps to Z. So we are being given a non-empty string containing only digits, and we have to determine the total number of ways to decode it. So let's take an example. Let's say we have the string 1, 2. So what are the different ways to decode this string? The first one is to take single digits. That is, take 1 and 2 separately as single digits, and this will map to AB. The second way is to take 12 as a double digit, which will map to L. So for this string, the output will be 2. Let's take another example. So we have this string 1, 2, 3. The first way to decode this will be take single digits 1, 2 and 3 separately, which will map to ABC. Another way will be to take 12 as a double digit and 3 as a single digit, which will map to LC. Lastly, we can take 1 as a single digit and 23 as a double digit, which will map to AW. So for this example, the output will be 3. So at each step, we have to take care of two things. Either we have to take a single digit or a double digit. And the double digit has to be less than or equal to 26. So let's take another example. We have this string 1, 3, 2. So one way to decode it will be taking single digits 1, 3 and 2 separately, which will map to ACB. Next, we can take 13 as a double digit and 2 as a single digit, which will map to MB. Lastly, we can take 1 as a single digit, but we cannot take 32 as a double digit because that is greater than 26 and 32 doesn't map to any alphabet. So there is an invalid decode, and the output in this case will be 2. We also have to consider the presence of 0. So what happens if there is 0 present in between the strings? So let's see how we can decode this. Since 0 doesn't map to any alphabet, we cannot take 0 as a single digit. So this is not a valid decode. But what we can do is, we can take 0 with 1 or 2 to make double digits 10 or 20. So in this case, we can take 10 as a double digit and 2 as a single digit, which will give us JB. Lastly, we can take 1 as a single digit, but we cannot take 0, 2 because any digit cannot start with 0 and 0, 2 doesn't map to any alphabet. So this is not a valid decode. So in this case, the output will be 1. So there are two different ways to solve this question. We can use depth first search using recursion, or we can do it iteratively using dynamic programming. So in this video, we will look at both of these ways one by one. So let's first start with depth first search using recursion. So what DFS does is, it searches every index before moving on to the next one. And using recursion, at every index, we will take a single step and a double step. Single step means taking a single digit, and double step means taking double digits. Since we are using recursion, we also need our base cases. So the first base case is that whenever we reach the end of the string, we will return 1. And the second base case is, if we have a 0 in the string, we will return 0. That means 0 cannot be taken as a single digit. We also have to check for some certain condition. And the condition is that the digits has to be less than or equal to 26. When the conditions and base cases are satisfied, using recursion, we will go depth first into our search. So let's see how we can do that. So let's say we have this string 1, 2, 3. So at one side we're taking a single digit 1 and on the other side we're taking a double digit 12. We will repeat the same step for every subproblem. So for this subproblem, we will repeat the same steps, which is taking a single digit 2 at one side and taking a double digit 23 at the other side. Since we have reached the end of the string for this subproblem, and also since 23 is less than 26, this is a valid decode. So we will add 1 to our output. And our output now becomes 1. Next, we will repeat the same steps for each subproblem. So for this subproblem, the only digit that we are left with is 3. So we will take 3 as a single digit on this side, and we have reached the end of the string. So we will add 1 to our output, and our output now becomes 2. Repeating the same steps for this subproblem, since we are only left with 3, we will take 3 as a single digit on this side, and our string is also completed, so we will add 1 to our output, and our output now becomes 3. So the result for this solution will be 3. Let's take another example. We have taken this string 2326. In the beginning, the output is 0. So we will repeat the same steps for this problem. On one side, we are taking a single digit 2, and on the other side, we are taking a double digit 23. We will check for the conditions that all the digits have to be less than or equal to 26, and we will move forward. So moving forward, on this side, we have taken a 3 as a single digit and taking 32 as a double digit. But since 32 is greater than 26, this is not a valid decode. So for this subproblem, we stop right here. Moving further for this subproblem, on this side we are taking a single digit 2 and on this side we are taking a double digit 26. And for this subproblem, we have reached the end of the string. So we will add 1 to our output, and our output now becomes 1. Moving forward, for this subproblem, we repeat the same steps. On this side we are taking a single digit 2 and on this side we are taking a double digit 26. Since we have reached the end of the string for this subproblem, we will add 1 to our output, and our output now becomes 2. So moving forward, for this subproblem, the only digit that we are left with is 6. So on this side we are taking 6 as a single digit and we have reached the end of the string. So we will add 1 to our output. Our output is now 3. Moving further for this subproblem, we are taking 6 on this side and we have reached the end of the string. So adding 1 to our output now becomes 4. And we have also finished all these subproblems. Now that we know how we can use DFS using recursion, let's see what the time complexity will be. So the time complexity for this solution will be exponential. That is, we go of 2 to the power n. And this is not a great solution, but we can improve it. Let's see how. So if you look closely, this subtree and this subtree are identical. We are taking 2 as a single digit on this side and 26 is a double digit on this side. And we are doing the same thing for this subtree. So using memoization, we can create a map which will store the indexes and the ways to decode that problem at that index. So let's see how we can use memoization. So using memoization, we have created a map to store the index of string as the key and the ways to decode the string at that index as the value. So what I mean by that is, we have this tree, and since we are using depth first search, our recursion will move to the last index, which is 3 in this case. So coming at the third index, we have the value 6. So the ways to solve 6 is only 1, since 6 can only be used as a single digit. So in our map, at the index 3, we have the value 1. So moving at the second index, we have 2 and 6 after that. So what are the ways to solve 26? Either we can take 2 and 6 separately as single digits, or we can take 26 as a double digits. So at index 2, the value will be 2. Next, moving on to the index 1. So at index 1, we have the value 3, and after that 2 and 6. So what are the different ways to solve this problem? Either we can take 3, 2 and 6 separately as single digits, or we can take 3 as a single digit and 26 as a double digit. But we cannot take 32 as a double digit since that is not a valid approach. So at index 1, the value will be 2. Now we come to the 0 index. So at 0 index, these are the different ways to solve this string. Either we can take 2, 3, 2, 6 and separate single digits, which will give us the string BCBF, or we can take 2 and 3 as single digits and 26 as a double digit, which will give us BCZ. Another way is to take 23 as a double digits, 2 and 6 as single digits, which will give us WBF. Lastly, we can take 23 as a double digit, also 26 as a double digit, which will give us WC. So at index 0, there are 4 ways to solve the string. So at index 4, we have the value 4. And this is our answer. At the end, this is what we are going to return. So using memoization, what we have done is we've created a map and we have stored the index of the string as key and the ways to decode the string at that index as the value so that we don't have to search the tree again and again. And this reduces the time complexity to big O of n. Now that we know what we have to do, let's see the code. So let's look at the code. In the beginning, I have initialized a function dfs which will take the parameters index and map. In the beginning, my index is equal to 0 and my map is just an empty dictionary. And in this dfs function, I have my base cases for recursion. So the first case is, if index is equal to the length of my string s, then I need to return 1. What we mean by that is, whenever we reach the end of the string, we have to return 1. And this one will be added to our output. The next base case is that whenever we find a 0 in a string, we need to return 0. Next, on line number 11, I'm using memoization and I'm checking that if that index is already present in the map, then I need to simply return the value at that index. And this will give me the ways to decode the string at that particular index, and I don't have to search the tree again and again. Next, I'm checking for my conditions that for the double digit index plus 2, the length of the double digit has to be less than or equal to the length of my string, and the value of the double digit has to be less than or equal to 26. If these conditions are satisfied, then I have two variables, single and double. Single is for the single digit and double is for the double digit. And for both of the variables, I'm calling the function dfs and passing the parameters index plus 1 for the single digit and index plus 2 for the double digit. I'm also passing the map, which is in the beginning just an empty dictionary. Next, using recursion, when I've searched all the tree depth first, in the map, I will add that index and the values to decode that string as the value. That will be single plus double. And if this condition is not satisfied, it means that our double digit is greater than 26. So in that case, in the map, I will only add the single digit, which is index plus 1. On line number 21, at the end, I simply have to return the value of my map. On line number 24 and 25, I have created my map, which is an empty dictionary. And at the end, I am returning my function dfs, in which I have passed the parameters 0 as the index and my empty map. So this was the code for the recursion solution. Now let's move on to the second solution, which is using dynamic programming. So let us now move on to the second solution, which is the iterative solution, and we are doing it using dynamic programming. So first we need to understand a concept, which is the concept of passing the inheritance. So just like a father passes his inheritance to his child, for our solution, this is exactly what we are going to do. So just like a father passes his property to his child, as we move along the generation, the number of houses increases. Let's say we have a grandfather who has one house. So he passes the property to his child. The child purchases another house, and now the father has two houses. Now the father passes his houses to his child, and the child purchases another house, and now the child has three houses. So what we are simply doing is, as we move along the generation, we keep adding the number of houses. And for our solution, this is the concept that we are going to apply. So let's see how. Let's say we have a string 1212. So in the beginning, we have taken a single digit 1, and the ways to decode this 1 is only 1. But when we have two digits, 1 and 2, how many ways are there to decode this 1 2? Two ways. Either we can take 1 and 2 separately as single digits, or we can take 12 as a double digit. So the number of ways have increased. When we move on to the next number, 121, the number of ways to decode this 121 also increases, which is 3. When we move on to the next string, 1212, the numbers to decode this string is equal to 5. So what we are doing is, as we keep adding number of digits, the number of ways to decode that digit also increases. So we have a string s 1212, and in the beginning we have initialized a DP array, and the size of DP array is equal to the size of a string, which is 4. And in the beginning, all of the digits in our DP array are 0. So the first step is to initialize the first digit in our DP array to 1, because the ways to decode this single digit is 1. The second step is to iterate over the array, and we will start with the first index. And in that for loop, we have two variables, single and double. Single stands for a single digit and double stands for a double digit. So the single digit at this index is 2, and the double digit at this index will be 12. So now that we have x equal to 2 and y equal to 12, we are going to check some certain conditions. And the conditions are that the single digit has to be between the values 1 and 9, and the double digit has to be between the values 10 and 26. When these values are satisfied, what we're going to do is, for this single digit, we are going to add the value of the previous index to the current index. So this 0 now becomes 1. And we are going to repeat a similar thing for our double digit. What we are going to do is, we are going to add the value of previous 2 index to this current index. So in my DP array, at the current index, I will add the value of index minus 1 for the single digit. And the current value in my DP index for the double digit, I have added the value of index minus 2. But since we are currently at index 1, for this case, we can simply add a 1. So now the current value at my index 1 becomes 2, plus 1 for x and plus 1 for y. And now we move further. So moving further, we come at index 2. The value of the single digit at index 2 is 1, and the value of double digit is 21. So x equal to 1 and y equal to 21. We check for the same conditions and we do the same thing. For the single digit at the current index, we simply add the value of the previous index. And for the double digit, we add the value of index minus 2, that is 1. So at the current index, we have plus 2 for the single digit and plus 1 for the double digit. And now the value becomes 3. Moving further, we come at index 3. And at index 3, the value of single digit is equal to 2 and the value of double digit is equal to 12. So now that we have x equal to 2 and y equal to 12, we repeat the same thing. We check for the conditions, and at the current index, for the value of x, we add the value of the previous index. And for the double digit, we add the value of the index minus 2. So this will now become plus 3 and plus 2. And the final answer is 5. And at the end, this is what we need to return, the last value in our DP array. So as you can see, as we move further, the ways to decode the string also increases. So the time complexity for this solution will be big O of n, and the space complexity will be big O of 1, since we are not using any additional space. And now that we know how to do the question using dynamic programming, let's see the code. So the rules for the giveaway are following. 1. Subscribe to the channel. 2. Like the video. 3. Comment hashtag decodeways and hashtag decodeways LEETCODE in the comment section below. And for more information, you can check out our Discord group or Facebook group. All the links are given in the description below. And now let's see the code. So following the same step that we just discussed, in the beginning I have initialized a DP array which is equal in length as the string s, and in the beginning all the digits are equal to 0. Next we have to initialize the first digit in our DP array equal to 1. And the next part is to iterate over our array and starting at index 1. So my x is equal to the single digit and my y is equal to the double digit. X will be equal to the value at the current index and y will be equal to the value at the previous index till the value at the next index. Next on line number 14, we have to check our conditions. So for the single digit x, it has to be between the values of 1 and 9. And when it satisfies the conditions, in my DP array, at that current index, I'm going to add the value from the previous index, which is DP I minus 1. Similarly, for the double digit y, I'm checking the conditions that it has to be between the values 10 and 26. Next, I have to check the conditions that at the current index I minus 2 has to be greater than or equal to 0. In that case, in my DP array at the current index, I will add the value of index I minus 2. Else, in my DP array at the current index, I will simply add 1. And in the end, I simply have to return the last value in my DP array, which is our answer. So this was the code for the iterative solution, which we have done using dynamic programming. Thank you so much for watching the video. Please don't forget to subscribe. Thank you.